Let's talk about perimeter and area. Today we're going to focus on triangles and quadrilaterals. Let's begin. So if you remember that a rectangle has a base and a height, and you can find the area of base times height or length times width. You can also look at this parallelogram below here in blue and recognize that if you were to cut this triangle on the left off, because this is the height, and translate it to the other side, we do create a rectangle. So you should be able to conclude that a rectangle and a parallelogram have the same formulas for area. The area of a parallelogram with a base and a height is area equals base times height. Now remember that the height of a parallelogram is that distance of the segment perpendicular to a line containing the base. So it is possible the height could be drawn outside of the parallelogram. Let's look at some examples. So if you look here, we have a parallelogram which is right here. But in order to find the area of the parallelogram, we need to know the different parts. Area is what we're trying to find. The base is 11. The height we don't know, but we can find it because if this side is 34, we know this side is 34 millimeters. And now we can use Pythagorean theorem in order to find the height of the parallelogram. So we have 30 squared plus h squared equals 34 squared. So going through and solving, we subtract our 900. That gives us that h squared is 256, and of course we remember to take the square root. So we know we want that positive length, which is 16. So now we have the formula area equals base times height, and we can plug in what we know. We know the base is 11 and the height is 16, so when we multiply, we get the area of the parallelogram is 176 millimeters squared. I want you to notice a couple of things. One, I wrote down the different parts of the equation so that I know what I have. Two, I wrote the formula down in order to substitute in. Any side work is over to the side, and I'm working vertically down the page. Let's look at another one. Now we want to find the height of a rectangle in which we're given the base and the area. So if we make our list, we know the area is 8x squared plus 24x minus 12. Our base is 4. The height is what we're trying to find. So when we write our formula, area equals base times height, we can substitute in the information we are given. This may look difficult, but in all reality, all we have to do is divide both sides by 4 in order to get h by himself. Now that's a 4. Now be careful when you divide, because we have to divide all 3 terms by that 4. And when we do that, we have 2x squared plus 6x minus 3 is our height. And then don't forget to put your units of measure, and in this case, inches. And if you want to go just one step further, you could go back and substitute h in up here and distribute the b to make sure that we do get a. Now let's look at this one. We need to find the perimeter of the square in which we're given the area. Now hopefully you remember that with a square, all 4 sides are the same, so our side lengths should be the same. So if we're given the area, we need to work backwards. Well, you need to start realizing that the x squared means it's a quadratic, so we should be looking to factor. So here's where we do the a times c, which is 36. List your factors. which ones add up to give us b? In this case, it is the 6 and 6. So now we rewrite 4x squared plus 6x plus 6x plus 9, and now we can group our terms. In this first one, they have a 2x in common, which leaves us with 2x plus 3. In this second set of group, or the second group, they have a 3 in common, which leaves us with 2x plus 3. Now within our two terms, they both have a 2x plus 3 in common, and leaves us with a 2x plus 3. Now this should make sense since the lengths of the square are all the same. So in this case, they're all 2x plus 3. But since we're wanting to find the perimeter, we now need to remember that the perimeter is 4 times the side length. So here our side length is 2x plus 3. So when we substitute in and simplify, we get the area is 8x plus 12 centimeters. And that is your perimeter. Let's move on to triangles and trapezoids. These formulas are on your formula chart, but make sure that you understand what each of the parts are, remembering that the height still has to be perpendicular to the base. So here we need to find the base of a triangle in which the area is 15x squared centimeters squared. To find the area of a triangle, it's 1/2 base times height. Let's make our list. Our area is 15x squared. That's all from here, so now let's look at the diagram. 5x is your height, and we're trying to find the base. So now we substitute in. Our height is 5x, and we're still trying to find the base. Let's get rid of that fraction. Remember, to get rid of the fraction, we can multiply both sides by the denominator to get rid of the fraction. So that leaves us with 5x times b, and over here we now have 30x squared. To get b by himself, we divide both sides by 5x, which gives us 6x as the base. Don't forget to put your units of measure. Let's look at this trapezoid. The formula for area of a trapezoid is 1/2 base 1 plus base 2 times the height. Remembering that the bases are the parallel sides and the height is the perpendicular segment connecting the bases. So over here we make our list. We have area, the base 1, base 2, and the height. Those are all the variables in the equation. Well, here we're given the area. Over in the diagram, we're given base 1. We need to find base 2. And we know here is our height since it's perpendicular down here. Even though it's not inside, it is still the height of the trapezoid. So now we can substitute in. What's the first thing we should do to solve? Well, we could go ahead and divide both sides by 11 and go ahead and get rid of that. That would leave us with 21 equals 1/2 times 23 plus base 2. Now we can get rid of our fraction. Could we have gotten rid of our fraction first? Absolutely. I just wanted to deal with smaller numbers. So now we have 42 equals 23 plus base 2. Subtract your 23, and we are left with 19 millimeters as our base 2. Now the rhombuses and kites, they have the same formula, which is 1/2 diagonal 1, diagonal 2. If these are not on the formula chart, you may not add them to them. This is something you need to remember. And notice that the D's stand for the diagonals. So let's look at this example. So if you remember the formula we just looked at, 1/2 diagonal 1 times diagonal 2, we can now make our list. Area is what we're trying to find. Diagonal 1 is 8x plus 7. Diagonal 2 is 14x minus 6. So let's substitute in. Hopefully you notice we need to distribute. So that gives us 8x times 14x, 8x times a negative 6, 7 times 14x, and 7 times negative 6. Look to see if you can simplify inside your parentheses, and here you can. Now we need to distribute this 1/2. And it may not look pretty, but this is the area of this rhombus. Let's look at this kite. Now you notice with the kite we do not have the full length of diagonal 1 and diagonal 2, but that is the same formula that we need. And when we're making our list, we need our area. Diagonal 1 we don't know, diagonal 2 we don't know. But if you notice, diagonal 1 would be whatever 28 plus x is. Diagonal 2 is going to be y plus y, because in a kite, this diagonal is bisected. So how are we going to find x and y? Well, if you remember, the diagonals are all perpendicular to each other. So we have 4 right triangles inside. So if you have 2 sides of a right triangle, as in this triangle right here, we can use Pythagorean theorem in order to find the missing length. So 28 squared plus y squared equals 35 squared. When we go through and solve this, we get that y is 21. So here, 21 plus 21 is 42. So we now have diagonal 2. And we also know that this is 21, which now we can use Pythagorean theorem again in order to find x. And we get that x is 20. So when we substitute in up here, we get that the other diagonal is 48 units long. So now we can substitute in to our area formula. Area equals 1/2 times 48 times 42. And when we multiply these 3 numbers together, we get that the area is 1,008 inches squared. So keep in mind that to find area, you could use multiple formulas in order to get all the pieces that you need within that one area formula. So be looking out for those. Now this last problem I'm going to leave for you to do. Make sure you have this question worked out and answered in preparation for class on the 30th and 31st. Good luck, and if you have any questions, please come put them on the parking lot.